Hi everyone. So I'm so sorry for not being with you today, but I'll try my best to clarify and introduce the concepts to you. So what we are basically doing, another alternative for extracting the essential oil or the lipid or the wax from the rose petals, is that we will use a supercritical fluid. So what's a supercritical fluid? Basically, it is a phase that is not a liquid and not a gas, but it has a liquid-like density and a gas-like diffusivity. So where does that occur in the phase diagram? If you see in the phase diagram in the slides, that comes the supercritical phase, supercritical fluid phase. It comes at a certain temperature and a certain pressure, so that if you increase the pressure and or the temperature after that point, you will be still in the supercritical phase. So in our extraction, we are using carbon dioxide. And for carbon dioxide, the supercritical phase starts at 31.1 degrees Celsius and 73.8 bar. What's so special about the supercritical carbon dioxide phase is that it has no surface tension. So that will help a lot in penetrating, in that this fluid penetrating in the petals that we are using. Another thing is that that phase will have a gas-like diffusivity, so that will help going in, diffusing in the petals very fast. So those two factors, the low viscosity, so low viscosity and the no surface tension, in addition to the high diffusivity, those two will make the extraction much faster. So now if you see the process design that this diagram shows, it has some main parts, which are the carbon dioxide feed, a chiller, a pump that would increase the pressure, and another and a heating chamber, also a back pressure regulator, and a collection vial. So what will happen in this diagram is that the carbon dioxide will be fed, and in the chiller its temperature will be decreased into 5 degrees Celsius. And then in the pump will increase the pressure of that carbon dioxide into 50 bar, which will make it a liquid carbon dioxide. And then as it goes into in that box that you see, that has the heating chamber and the extractor, the heat will increase the temperature and the pressure to more than 31 degrees Celsius and 74 bar, which will essentially make it a supercritical fluid. And then it will go in the extractor that has the petals, and it will extract the essential oil. Depending on the pressure that we're using, and of course the temperature, we can decide what we want to extract from those petals. Do we want to extract the waxes or the lipids, or we want to extract the essential oil? So that depends on the temperature and pressure. But here, let's say we will extract the essential oil. So a good temperature is 50 degrees Celsius, and a good pressure is about 100 bar. And then after it leaves the extractor, the pressure will be decreased so that there will be a high relative volatility between the oil that was extracted and the carbon dioxide, which will basically make the carbon dioxide turn vapor, or basically it's a vapor liquid equilibrium, which will make the carbon dioxide turn to vapor, and then the essential oil will be collected into vials, and then carbon dioxide will be recycled and recovered. So advantages and disadvantages of this method using supercritical carbon dioxide is that first, it is a very fast extraction method. This method is the fastest to extract the first 50% of the essential oil that is in the petals compared to other methods. Another thing is that carbon dioxide is inflammable. It has no environmental hazards. Well, greenhouse effect are not considered hazard when compared to like contaminating water with hexane. So it's just not environmentally hazardous. Also, because of the relatively low temperature, it doesn't degrade the chemicals that is in the essential oil. Also, it has low energy cost, and the energy is being saved in this process. On the other hand, the disadvantages are two main disadvantages that are connected to each other. The first one is that it requires very high technology, which will generate very high pressures, and also so this high technology is not accessible to many countries, especially those poor countries. In addition, those high-tech devices are very expensive, so it will make the startup of buying those equipment a very tough thing compared to other methods. So this is all about the supercritical carbon dioxide extraction. So thank you for listening, and I'll hand the rest for the group.